Welcome, and thank you for joining us to gain new and actionable insights on site access. My name is Brent Sedlacek, the Director of Channel Development at Sterling, and I will be your host for today. As you can probably imagine, we have a big passion for site access and for keeping jobs on schedule and maintaining site safety. We are super excited that you're here to share your same enthusiasm and that you're joining us to learn about bridging the gap. Sterling, as a manufacturer, supplier, and contractor ourselves, works with EPCs, utilities, and contractors to really help you achieve your targeted project and business objectives. Bridging is definitely part of site access that can, if done properly, create the right solution and become a project enabler, and at the same time, minimizing risk. Today, our presenter for Bridging the Gap is Levi Frost. Levi has been in construction for over 15 years and is our Director of Construction Operations. In this role, he has managed our crews across the country as well as our equipment fleet. Previously, Levi has held leadership roles in project management and operational excellence. Most notably, and the reason he is a subject matter expert on this topic of bridging, is Levi was instrumental in our product development and managing the ideation, creation, and launch of our Terracross engineered bridge system. Also joining us today is John Finkeldy, a strategic account manager at Sterling and a licensed professional engineer. John brings over 25 years of experience in the construction space, along with engineering design, licensing, and permitting. John consults with a lot of large electric utilities, providing design and oversight of site access on high voltage transmission projects in the Northeast. So again, thank you for joining us. And at this time, I'd like to turn this over to Levi Frost.
Thank you, Brent. I want to just thank everyone else for taking the time today to join the call. And I trust that today will be a valuable, well-spent amount of time as we explore temporary bridging and the solutions available. Today we're going to cover starting with a safety moment, and we'll get into the nuts and bolts of bridging the gap, followed up by two different case studies, and then a time for Q&A and additional resources. Picked a safety moment today that relates to our topic area. I wanted to expand that a little beyond just working near or in water, but also anytime we talk about safety, I want to talk about how it relates to our personal lives, those around us. Safety needs to be a habit, a mindset, and a culture, not just something we do at work or a hat we wear. So I've put a couple slides up here just to remind us that we're coming into that time of year, whether we have kids, grandkids, take water safety seriously. It can cause tragic events quickly that can change our entire life. So I just want to put that reminder up before we get into kind of the details of specifically working near water. To talk about working on or near water, the first area that regulations, different rules we need to consider is we should always have a life-saving skiff. With that, we should have 30-inch life ring and 50 feet of suitable line. The only exceptions to this is if we can walk into the water and pull someone to safety without that need. So, ring buoys, also 90 feet of line, 200 feet between them for spacing. We're going to look at a lot of different scenarios today where we're working in moving water or standing water, but these are all things we need to consider. First aid or CPR, also something we need to have. Combine that with working with the buddy system. We should always have someone else with us when we're working around water. and then proper personal flotation devices. When we talk specifically to engineered or non-engineered temporary water crossings, we should always inspect them before crossing them. It's not only while we're building them, but we also need to consider the risks before we cross them and take ownership in monitoring and inspecting those crossings. So looking at the different scenarios that we'll consider as we talk about bridging today, there's a lot of unique attributes to these different areas. Naturally, when we think of waterways, I know my mind goes to moving water, open water, creeks, rivers, when I think of bridging. But it actually spans over a much wider range of things. So ditches, really a rapid grade change, or just an entry ditch, typically dry, solid soil bearing. We get into wetlands. This is typically standing water or constant water. Naturally, you're going to have a different soil bearing. Brings in a lot of additional environmental considerations. Underground utilities or infrastructure. We're showing pipeline marker here, but that goes into ductwork, drain tile. Really what we're trying to avoid here is any type of compaction or compression of the soil that could damage those resources. The last area is elevated obstructions. There's times out in the field where we're going to come up against an area that we just can't remove an obstruction, or it's not cost effective to do so. The example we have here is railroad tracks and just making that smooth transition over, protecting the rails or whatever asset is crossing by a type of bridging solution. What I really want to stress before we get into the different solutions is it's all about risk management. There's many risks associated with poor planning or lack of knowledge when we talk about selecting and constructing the right crossing. We're talking environmental, regulatory repercussions, potential loss of property, or even death. We really have to ask ourselves two questions right away. What's the potential impact of my decisions and actions, and what's the severity of the outcome possible? There's a picture here of just an example of crossings are a risky part of the construction business in the field. There's a lot of things to consider, and there's just too many variables that can make things go wrong. This picture is a timber crossing that was the result of a flood event that came in quickly and unexpected. These timbers being pushed down the right-of-way naturally are going to cause potential backing up of water and many different issues that compound quickly. So we need to make sure that we're managing the risk and planning for it on the front end as we build our crossings. Naturally, near and dear to my heart is field ingenuity. I started in the field and have come up that way, and I think it's important that we appreciate what the field can do. I think there's a lot of things that we do are more of an art than a science, but anytime that we can take that information and we can get ahead of it, we can plan for it, we can mitigate more of the risk. So construction is naturally a fine balance between schedule, cost, mitigating risk. All those things have to work together. So it's critical when we're setting up the job that we're preparing our guys in the field with clear direction and plans, clarity of the limitations and potential risk, and just giving them the proper tools and products for execution. The guys in the field just want to get it done. That's what they're there for. They are very creative. They will find solutions with what they have, and it's critical we give them the right tools to be able to do that safely and stay within time and budget. These pictures here are of a canal crossing, and this was some storm work that came up last minute notice. I just thought it'd be a neat picture to include to just, kind of appreciate this was not a planned crossing in any way. This was a storm crossing that popped up. The engineered bridge you see there was a pedestrian bridge that could not take heavy enough equipment for this situation. And on a moment's notice, the guys put this together. So just kind of talks to that ingenuity and how do we take those guys and their art, right, and turn it into a science.
With that, we'd like to go into a quick polling question. Up on your screen, you should see a question of how many temporary crossings do you typically have on a project? If you could select an answer, we would appreciate that. We'll give you 1 minute to do so. Thanks. Great. It looks like we have a lot of responses in here. Thank you for that.
I appreciate the feedback. Yeah, a lot of this comes to how we define a crossing, right? Looks like the large percentage here, you're seeing, really 0 to 4 crossings on a project, depends on the scope of the project, the size, the duration, and we'll talk through some of that and how the right product also fits that as we get into the details. So as we're understanding the product solutions, I just want to really take a little time to talk about all the different options that are available out there. Some of these are non-engineered, some are engineered, and some are a combination of components of both. In recent time, we have really seen a trend of increased requirements for engineered temporary crossings. And so I want to make sure, I'm sure there'll be some questions about that and where the future is going and what we see that looking like. So what I wanted to go through today is look at these different options really from what I would call a simplest to most complex crossing. So naturally our first option is solid matting or fill, if that's an option. So very safe, heavy on materials, a lot of potential environmental impact. A lot of this depends on how much time it's going to be installed and if it needs to be removed after. This picture is an example of a wetland where it was solid matting made the most sense to get through based on soil bearing and those different things we had to consider. Next option would be culverts. Again, this is a very safe option. It does bring a lot of environmental impact and things that have to be considered, whether water flow restrictions, permits. Again, it comes down to cost of material, how long it's going to be in, and what the requirements are there. Timber mats would be the next area. It's a very common usage in the industry. Timber mats are not an engineered product. They can do some type of engineering calculations for specific lift plans or bridging scenarios as needed, but it's typically going to be based on wood grade species, and it's a very conservative approach. It's hard to engineer the solution. This really is usually left to a level of comfort by the guys in the field and what's needed for layers, and can definitely leave some room for error there. Engineered mats would be the next one. You see multiple different products out there that are made of engineered components, whether it's steel incorporated into them or glued products, different things like a CLT mat that does have engineering specifications to it. Typically, these are a limited capacity in what they can span, but they could be integrated with other products as well to put the engineering numbers to it to verify the safety. looking at this picture, what you're seeing here, this yellow line here across the bottom that's a rail car. So industry adaptations is also something we have to consider. Rail car is a great example of that, where wheels are removed and these are used in the right of way for spanning. A lot of times these rail cars are taken and then additional gussets or supports added to them to hit the required span and load capacities, but another option that's out there. We touched on it in the introduction just a little bit. Modular engineered is another form that our TerraCross fits into this well. So it's all engineered components that are then assembled in the field. So it makes for very versatile shipping in, movement of pieces, smaller equipment to assemble it, but it's a fully engineered solution. Prefabricated bridges. These are offsite manufactured, typically used in the highway world. So depending on what it's built for, maybe a big amount that has to climb up, typically designed to fit into a keyway or an abutment of some type as well. Very heavy in their pieces, typically only 2 or 3 pieces bolted together on site, some alignment that needs to fit together there as well. And then the last section would be floating systems or barges. These areas are what I would consider your higher risk and also requiring specialized equipment, but it really opens up the opportunities for difficult spans.
We're going to go into a second polling question now. And based on all of those different styles of solutions, the question here is, what % of your crossings required an engineered solution? Great. Thank you for that feedback. Levi, I'll share that poll with you.
Yeah, again, thank you for the responses. One of the questions looking at this data, I think we're seeing that a lower percentage, typically as we're talking about just volume of crossings, that's a natural response, I think, but as stated earlier, I think we're seeing a trend or a push toward a more engineered solution. This is one of the questions we see a lot is, when do I know that I should use an engineered solution? And I think the answer is in line with our earlier discussion that it's all about risk management. What's the potential impact? My example to that, I guess, would be am I bridging a dry, shallow ditch, or am I bridging over a moving large waterway? Do I have enough experience and confidence that I trust a non-engineered solution in this situation? And where does the risk fall ultimately? So moving on to benefits of proper planning. We need to consider all these things are a result of proper planning. Elevated safety, mitigate property damage, schedule attainment, environmental protection, and cost reduction. Naturally, when we plan ahead and all these things work together and in harmony, that's when the project all comes together, right? And the ultimate result is attained. Project assessment, as we're planning for what bridge specifically to a project now, as we're getting a little bit more into the details of how we decide on how we select the right solution. The time frame is a key indicator. Will there be shifting of outside forces? Are we crossing over seasons? Will there be different weather events? Time frame is a big driver, especially on cost and budget. Whether we can justify installing culverts instead, just different things we need to consider that are driven by time frame. Number of crossings per project. Again, can I use the same crossing that's a modular style? Can I move it down the right of way? How does the schedule all work together? How versatile is the product? Frequency of use. How many times will it be crossed? Do I have to worry about shifting, stability? What kind of range of equipment will be going over that crossing? Ownership and inspections is a big one. Who's going to take that ownership? Who's going to watch for shifting of it? Will there be different contractors on it or just one? What's my risk there? And then what's my planning window? How much time do I have to get the proper pieces in place? What am I looking at for product availability, freight, timing? Once we've looked at the project as a whole, then we need to look at job site evaluation specifically by location. So a lot of these projects may have multiple crossings. Like I said earlier, is one bridge allowed to be moved and used in multiple locations, or is it too specific by location? So things that we need to consider there is flexibility of location. Do I have multiple crossing locations to compare? Can I move it one way or the other within the right of way? That maybe more stable banks or a narrower crossing. What's my accessibility into the site? Do I have defined haul routes, load limits bringing things in? What's my environmental impact? Soil disturbance? What's my symmetry on each bank that I'm dealing with? Weather expectations, is flooding possible? Am I in a floodplain? Proximity to the general public. What are the potential risks downstream with the type of crossing that I'm considering? My working area, are there overhead obstructions? What can my potential work pad look like? And then one of the big ones is bank stability and makeup. What kind of soil do I have? What kind of slope on the banks? Is it a moving water? Is it undercutting on the bank? Do I have anything compromised there that I need to consider as well? Once we've looked at all the job site evaluations and really what builds up the strength of the unit and the unit that we're going to choose, it's what does it need to hold? What's the forces from above? And that's equipment analysis. I think too many times we take the worst case scenario and we figure that will cross over. But there's too many variations when we talk loading that we need to consider. We need to look at multiple aspects. So all these different pieces of equipment can act differently on the bridge, whether it's wheeled versus tracked, load distribution, vehicle length. Do we need to consider the elevation changes? Are the axles too spread out that we can't get over it without the piece essentially bellying out? What's our travel path width? Are we loading in a place that the bridge can handle it? And just overall specifications. Do these pieces of equipment have accessories, counterweights, different things that can be sent over the bridge separately? We need to understand the equipment before we select the right bridge. Environmental considerations, another major driver that control how we think about everything. Naturally, we should be picking the best solution environmentally as well, but from a time perspective of pulling permits, time of year, restrictions, regulatory restrictions by area, all those things we need to understand. And then what does the bridge allow for how I include control devices? Am I in a floodplain? This bridge here is the Terracross 40 that naturally will allow you to put geofabric incorporated right into the design. Our first case study was a unique situation where we had a customer crossing that was in place that they used for hunting and some different recreational things. The bridge was not in great quality, but the customer saw it as something that needed to be protected. We were looking at about a 25-foot water crossing. It was really the only place that we could cross, so we needed to cross by elevating over the bridge with very minimal soil disturbance. An engineered product was required. There were 4 other crossings on the project that worked chronologically, so we figured with the right solution we could move it down the right of way and save on bringing multiple units in. And it was critical that we did not leave any debris in the right of way. external factors, narrow rural roads, accessible from the east side only, and the west bank was a little uneven, which made some tricks for minimal soil disturbance requirements. So the right solution that was picked here, naturally narrowed down by being an engineered solution, but with the 25-foot clear span, the 40-foot terra cross allows for a 35. It also gave us the ability to shim up on both sides. With the right equipment, we could set from one bank, as you're looking here. One load that was not overweight, not over width, it was able to get into the tight locations. And then we were able to shuttle all those pieces down this what I would call a logging road and put in place for a one-day install. The pieces all being so modular could quickly be picked up then, loaded back out, and moved to the 4 other locations to hit their time schedule and only have to build one bridge into the budget. The second case study that we're going to look at was a little more difficult. This was 80-foot water crossing in a high security facility. The goal was to safely transport a control house across the water. And what we were dealing with was a low clearance delivery trailer, very gradual elevation changes, minimal deflection allowed, and we're looking at the potential of moving water and very deep banks. So the solution was a combination of a couple different things. This was a barge system that was lowered down into the water to give us our buoyancy and the height we needed for the minimal elevation change. Some excavation and leveling was also required to meet that gradual change. And then the barges were tied to some dead man anchors that were engineered and put into the banks to tie off. And then timber matting was used as a bridge across and tying in. You'll see the bank stabilization required there with a stack of timbers, and also to minimize that span of that timber mat to ensure that it had the structural integrity to take that span across from one side to the other. So pretty good example of another combination of some engineered and non-engineered components to get us the right solution. So in summary, what we need to start with is put a plan together for success. Communication and knowledge is the key. We need to mitigate our risk by understanding all the potential impacts and act accordingly. If there's any way that we can cut risk out of it, we need to. Of course, we also understand that there's no need to throw money away, and there are times that non-engineered solutions are also adequate, and that's where we need to assess all the available solutions and leverage our resources. And I think that by doing that we can come to a right solution that is best for everyone.
Great. Thank you very much. Appreciate that, Levi. At this time, we will go ahead and open up for questions. So if you can type in any questions you have in the question box, we will go ahead and answer as many of those as we can. First question. Besides unmarked KMZ files, our main utility does not provide detailed requirements on bridge specifications. Is this common?
Brent, can you repeat that question? You cut out just for a second.
Sure. Besides unmarked KMZ files, our main utility does not provide detailed requirements on bridge specifications. Is that common?
Yeah, I would say that is common, and that's where, as we talked about today, you need to consider all the factors and what the right solution is. You know, by getting out there, getting eyes on the solution, and understanding all the different considerations, we can come to the right solution, whether or not it's spelled out for us.
Our next question: how important is a geotechnical analysis of the soil on an engineered crossing?
Yes. Again, depends on the situation. So how much are we pushing the limits? You know, all of these engineered solutions typically have a specified amount of load bearing on each bank that they're taking. whether we're pushing the limits. A lot of times a pre-engineered solution, such as, let's use the Terracross 40 as an example. It's good for a 35-foot clear span. The case study that we used here was a 25-foot. So you're way back on the banks, and in doing that, knowing just from experience that qualifies and it will be adequate. But there are definitely times where we see some softer soils, or soils that are not quite so what I would call cohesive, or some bank slopes that we need to do some compaction tests to really know that things are safe and can hold up for what we're dealing with.
Our next question, do you often see a need to leave these solutions in place permanently, and does that change the options?
So these are all temporary solutions. Depending on the solution, how it's tied in, it can be in, we have bridges that are in for a year at a time on large projects. Now, obviously, they are temporary solutions. We need to have a check and balance in place that we're inspecting and monitoring these, but they are not permanent solutions, anything we visited today, other than maybe short of a culvert or something like that.
Can you speak to typical design responsibilities for who designs the different aspects of the engineered solutions? For example, who provides the following: load rating, abutment design, connection to abutment design, etc.?
Yeah, so that would all come through as who's supplying the product. So if the product is something, obviously we're talking engineered solutions. If we're taking components that are all tied together, it would be an engineered plan from an outside engineering company that would put those components together. If we're talking a already pre-designed, such as the Terracross, where you're taking steel components that are engineered components, and then an engineered CLT mat that ties all the strength together, that would come through that same path. Pre-manufactured, larger, what I referred to as like a highway bridge, same type of thing. Those would all be built through the specs, and it would come through the manufacturer or supplier.
Next question, do you provide a warranty for permanent engineered solutions? And I think maybe the answer to your question previously was these are temporary solutions. So maybe answering the question of, do you provide a warranty for temporary engineered solutions?
Yeah, so it's all about where the risk falls. If it's up to the contractor to supply and specify the bridge and install the bridge and guarantee that bridge as a crossing, that responsibility and that risk falls on the contractor for sure. And that would be in our queue. Speaking from a permanent situation, like I spoke earlier, none of these are permanent solutions. There are permanent solutions out there, especially as we talk about some of these pre-manufactured solutions, and that would naturally drive a different conversation as far as the footings, the abutment, all those different things we talked about. But it would be an engineered solution that would flow through and could be discussed on specific situations.
Next question. Would you prefer to meet at a site to do an assessment, and is that something that you offer to help design the most viable solution?
Yeah, absolutely. I don't believe you can come up with the optimal solution without getting eyes on the site. Even when we're working directly with a customer and they're confident that they know the width and kind of what they need, we still want to send somebody out to look at the site. There's too many factors to consider that can set us up for failure.
We do not usually put mats on top of timber mat bridges. How does that extra layer help?
Yeah, so in a lot of the pictures, what you saw here is a typical timber mats for what I would consider runners or stringers. That's your structural strength. And then a lot of our pictures, you're seeing a CLT mat, which is a cross-laminated timber mat, which is an engineered mat over the top. That's a very rigid mat. It's proven what it can do. There are calculations behind it. And the rigidity of that mat is spanning the weight across the other members running perpendicular to it. So what you're doing is distributing the weight. you're minimizing shifting, movement of your runners, and making that crossing a lot safer and a lot more stable, not only for who's crossing it, but for a longer amount of time.
Thank you for all your questions today. So whether we're minimizing risk, keeping a project on schedule, managing your budget, trying to maintain site safety, that's something that Sterling will do. We're happy to partner with you and provide the tools that you need to get the job done, or we can help you create and implement the best access solution for your job. You can also view existing webinars on our website, sterlingsolutions.com. On our website, we also have a number of case studies, white papers, and more product information. Thank you very much for your time, and have a great day.